Welcome back to the 90-Day AI Mastery course. Today is day 4, and we are going to learn one of the most exciting and fundamental concepts in programming, conditional statements. Up until now, our code ran strictly in a straight line from top to bottom. But real-world programs must behave like a brain, making decisions based on data. In this tutorial, you will learn how to use Python's conditional keywords to direct the flow of your program. We will explore simple decisions, multi-way branching, and nesting. By the end of this lesson, we will apply everything we learn by coding 2 real projects, a leap year finder and an advanced grade calculator with nested checks. Let us jump right in. Let us start with the most basic form of decision-making, the if statement. An if statement asks a question. It takes a condition, evaluates it as a Boolean expression, and if that expression is true, it runs the code block directly beneath it. Indentation is absolutely critical here. Unlike languages like Java or JavaScript which use curly braces to group code, Python uses indentation. We indent the code block by exactly 4 spaces. If the condition is false, Python skips that block. To execute a different block of code when the condition is false, we use the else statement. The else statement acts as a catch-all. It has no condition of its own, it simply executes if the preceding if condition was not met. Let us see if and else in action. In this code block, we declare a variable called age and assign the integer 16. Then, we write our conditional statement. We check if age is greater than or equal to 18, followed by a colon. Because age is 16, this expression evaluates to false. Consequently, Python skips the indented print statement directly underneath the if. It jumps straight to the else keyword, reads the colon, and executes its indented block, printing "You are not old enough to vote." This is basic control flow, directing the execution path dynamically depending on variable values. Often, you have more than just 2 paths. If you are coding a traffic light system, the light can be green, yellow, or red. If you only had if and else, you would have to write complex, messy logic. To solve this, Python provides the elif statement, which is short for else if. You can add as many elif statements as you want in between your if and your final else. Python checks these conditions in order, from top to bottom. The moment it finds a condition that is true, it runs that specific block and skips the entire rest of the chain. If none of the conditions are true, the final else block runs. Here is how the if-elif-else ladder looks in code. We have a variable light holding the string yellow. Our program checks if light equals green. Since that is false, it moves to the first elif, checking if light equals yellow. This evaluates to true. Python immediately runs the corresponding print statement to output slow down, and then exits the conditional ladder. It does not evaluate the red check or the else check. This order of execution is very important to understand, especially when dealing with overlapping ranges. Sometimes, a decision depends on multiple factors in a hierarchy. For instance, to show a user's private dashboard, they must first have an account, and secondly, they must be logged in. You can represent this in code by nesting one if statement inside another. Each level of nesting shifts the code further to the right by another 4 spaces of indentation. Nested conditionals are powerful, but nesting too deeply can make your code very hard to read. In many cases, you can flatten this structure by combining the conditions into a single statement using logical operators like and or, which is highly recommended for cleaner code. On screen, you can see both approaches side by side. The first block uses nesting. If has_account is true, Python enters the first block and then checks if is_logged_in is true. Only when both are true does it print. Welcome. The second block performs the exact same logical checks but flattens them into a single line using the and operator. The flattened approach is cleaner and much easier to read, especially as your programs grow in complexity. Try to use logical operators to simplify your code structure whenever possible. Now let us build our first project, a leap year finder. A leap year contains an extra day, February 29th, to keep our calendar in alignment with the Earth's orbit. The mathematical rules for determining a leap year are a classic logic puzzle. First, a year must be divisible by 4. However, if it is divisible by 100, it is not a leap year, unless it is also divisible by 400. We can implement this logic in Python using nested if-else structures or a single flattened conditional statement using modulus division. Let us look at the code for both approaches. Here is the simplified leap year finder code. We take a year from the user, convert it to an integer using explicit casting, and calculate the Boolean variable is_leap. The expression checks if the year is divisible by 4 and not divisible by 100, or if it is divisible by 400. If this complex Boolean evaluates to true, we print that the year is a leap year. Otherwise, the else block runs. Modulus division using the %sign is the key here. Remember that a number is divisible by another if the remainder is 0. Our second project is an advanced grade calculator. We will take scores for math, science, and English. Unlike yesterday's simple version, we will implement input validation. If the user enters a score less than 0 or greater than 100, we will show an error message and refuse to calculate the grade. If the scores are valid, we will calculate the average, assign a letter grade from A to F, and use a nested if statement to check if an A-grade student qualifies for honors or honors with distinction. Let us examine the core structure of the advanced grade calculator. First, we use a comparison chain with the logical operator not to ensure all 3 subject scores fall within the valid range of 0 to 100. If they do not, we print an error. In the else block, we calculate the average. We then check if the average is 90 or above. If so, we assign grade A and status honors. Within that block, we check if the average is 98 or above to upgrade the status to honors with distinction. This demonstrates how nested conditionals refine our decisions. Outstanding work completing day 4. You have learned the essential mechanisms that allow your code to make intelligent decisions. Let us recap the key takeaways. First, indentation in Python is syntactic. It is not just for readability, it defines code blocks. Second, use elif for multi-stage decisions, and remember that Python stops at the first true condition. Third, nested conditionals represent hierarchies, but they can often be flattened and simplified using logical operators like and or. Tomorrow on day 5, we will explore loops, allowing our programs to repeat actions and process collections of data. Keep practicing, and I will see you tomorrow.